Hi, everyone. Welcome to Project Pro's industry podcast series, where we speak with leading industry leaders and researchers on the latest in ML, deep learning, and GenAI use cases. Today, we have Dr. Kamal Ali with us. Kamal has over 30 years of experience in AI, over 5 years specifically focused on deep learning and LLM. And his experience, he is, largely spread across some iconic companies with Yahoo in the very early days, where he spent almost 5 years as a data architect. And then he was a senior machine learning researcher at Stanford University. And he spent almost 5 years at Apple as a senior machine learning research scientist. And more recently, he's the chief data scientist at Simplifai. Today's session with Kamal is focused on the insurance GPT, which Kamal worked on, basically a GPT fine-tuned model focused on helping insurance claim handlers. Thank you so much for taking time to do this, Kamal.
Welcome. Okay, let's start. So I'm I'm a chief scientist at Simplifai, which is a company that does software for insurance, banking, and finance. And today, particularly, I'm going to be talking about InsuranceGPT, which is how we have adopted the large language models like GPT for insurance. We also plan to move to doing finance and banking later on. Okay. So the particular type of insurance we're going to be talking about is motor insurance. And it's basically a system that we have built called IGPT. And it is for claims handlers to make their job easier and faster and more consistent when dealing with car crashes and motor incidents. So as said previously, I have 5 years experience in large language models and deep learning, which is about the most anyone can have nowadays, actually. But I have 30 years experience in machine learning. My PhD was in mixtures of experts and ensemble learning. I have 40 reviewed papers, and I've done research at Stanford, IBM, Yahoo, and UC Irvine. I've worked as a startup, worked as a founder at a startup. I've been a consultant. I've been a research scientist and also a machine learning scientist in applied contexts for Apple News. So let me just start by saying a little bit about Simplifai. Simplifai is an automation platform for banking, finance, and insurance. Simplifai is being based in the European Union. It is very cognizant of GDPR and regulations regarding data privacy. And we have a footprint in 10 different countries with over 100 employees currently. So basically, the agenda for this talk is I'm going to present about 5 slides covering the trajectory of how we got from AI in the 1950s to where we are now. Then I'm going to talk a little bit about how InsuranceGPT provides value for our customers, and then there will be some question and answers. So first, let's talk about how we got from AI to machine learning to the large language models. So in the early 50s and 60s, AI started, and it was all about symbolic AI till about the mid-90s. The so-called good old-fashioned AI, GoFi, existed from 1950s to about 1990. The difference that started to happen in 1990 was emphasis on statistical machine learning, not symbolic machine learning. In statistical machine learning, it was not about logical deduction so much as looking for patterns in large amounts of data. And the emergence of the internet certainly enabled that new point of view to take hold. And once we started having the internet, we got even more data being uploaded, conversations from people, text, just reams and reams of data. So then the next breakthrough came in around the 2010s, so-called deep learning. So neural networks have been around since the 60s, but what we were unable to do was to learn neural networks that were deep, that had many different layers. We were only able to learn one or two layers, and that really limited what the neural networks could do. And what allowed this progression was partly hardware. Like we now have hardware that's millions of times faster than it was in the 90s and probably billions of times faster than the 60s. And also new algorithms, but mostly it was hardware and the scale of the data that was available from the internet. Then starting in 2014 or thereabouts, we started getting the adversarial GANs, networks, neural networks that would learn by competing against one another. We started seeing the start of generative AI that actually worked. So previous to that, we were limited to generative AI that was on the order of a sentence. That's all it could do coherently. From 2014 onwards, we started getting generative AI that could generate a paragraph that held together and made sense. And then since then, now we're at the point where we can generate stories. GPT-4 can generate stories that are on the order of several paragraphs long. I don't know what the longest is, but I would be surprised if it's more than a few pages. So that's where we are now. It's a few paragraphs, maybe a page. And finally, we have GPT. And now, as of this week, we have GPT 4.0 Omni that can do not only text, but integrate with vision, audio, and video. So the history of machine learning has been that big data trumps algorithm. People like myself, we are all interested in coming up with fancier algorithms, but actually that turned out not to be the right way to do things. If you just took a lot of data, you could get away with a pretty dumb algorithm and it would still do better than the smartest algorithm with a small amount of data. So big data is more important than smarter algorithms. In the 60s, we went from neurons to neural networks. And then in the 90s, we got lots of data, which helped. And then, as I said, we got the deep learning. In 2009, we also had a strange, some of the researchers in machine learning found that they could do a lot more by using graphics processing units. This came out of left field for us because not many of the researchers are that cognizant with hardware, especially GPUs. But GPUs allowed for parallel processing of matrix algebra operations that are at the key of the new types of deep learning and generative AI that we are doing now. Then we started getting transformers around 2014. So originally, transformers were transforming from one language to another, from English to French, for example. And then it became more general. It could be transforming from an image to a caption, or it could be transforming from text to an image. Like with DALL-E, you can give it a caption and it will generate a image of that caption for you. Around 2017, we did get a smart algorithm. It's called attention. And basically, it was also in the context of transformers or translation. Basically, the idea is that when you're translating words from English to French, it's never a one-to-one translation. You have to pay attention to different pieces of the previous sentence in order to generate the next word that you want. And then finally, in 2022, we have ChatGPT. And then for this talk, we have domain-specific GPT. So OpenAI's API and Hugging Face API have enabled companies like Simplifai to create domain-specific applications of GPT. And that's what we're really interested in. We're not interested in whether it is intelligent or can have a conversation per se, but what can it do that's actually useful in a business and enterprise setting? So the big ideas, like I said, data volume, hardware, scale, attention algorithm, transfer algorithm, and then this thing called zero shot learning or few shot learning, in which you can take the GPT and give it a very small amount of extra training and train it for your specific needs at your specific company. Okay, so, right. So what are the main functions of InsuranceGPT? It has to extract information from all kinds of documents that the claim handlers currently live in. Things like accident reports, police reports, and so on. These are not functions that the general GPT-4 knows anything about. So these are things that we have to fine-tune our insurance GPT to do. It needs to be able to summarize the case. So some of these car accidents have a dozen documents: police reports, witness reports, multiple accident reports, insurance policies, and so on. You have to be able to synthesize all that information together, bring it to the claim handler's attention. And that's what we're really all about, which is helping the claim handler, reducing the number of minutes they need to spend per case, and allowing them to be more consistent. If they say that you have to pay, or the other party that's having the car accident has to pay, all those judgments need to be consistent. They need to find the right types of laws that apply. And to do this, we actually have to do some reasoning. We have to say that law number 256 applies to your case, and why does it apply? And then they have to assess and do recommendations like, you have to make this much payment, or maybe it's the other person's fault and we're just going to wait for them to pay and for your car. Okay. So what kinds of data does IGPT use? IGPT uses insurance laws, which are specific to each country. So Simplifai is operating in a number of different countries. We have to use the laws of the correct country. We have to use the policy of the company that the person is insured with. We have to use damage reports that come from a garage. And we have to generate communications to the customer to let them know what the customer needs to do next. And then we have to inform the customer of the outcome of the claim, whether it was their fault or the other person's fault, and how much they might need to pay. And then how is IGPT trained? IGPT takes advantage of these pre-existing large language models, LLMs, things like GPT, Mistral, Claude, and the ones that are available for open use, for opening license. And then we can fine-tune them for our specific needs. So we can fine-tune them on things like the laws of each specific country, the policies of the company, and historical customer data. Maybe for your car accident, there was a previous car accident that was similar to yours, and let's look up what happened to that one, and that can inform us on how to proceed with your claim. So this is the user interface right now. You can see the uploaded reports are here on the left-hand side, and on the right-hand side, there is a bunch of little boxes that summarize things about the incident. In this case, this is for travel insurance, not car insurance, but we have a similar offering for car insurance. What are the risks of using ChatGPT-based systems? Well, in the European Union, there's a lot of concern about data privacy. So, in fact, we have engineers in India who cannot look at the data for our customers if the customers are in the European Union. We have to abide by GDPR and various ISO regulations. We have to restrict visibility outside the EU. We have to worry about hallucinations. So far, hallucinations have not at all been a problem for us, because what we do in the Insurance GPT is we have a modular system, and in our pipeline, we use GPT or the fine-tuned version of GPT and give it instructions that are very specific. So thankfully, we have not seen any hallucinations so far. And also, we have not really come across issues of bias so far. But maybe in a year or two from now, when things are more mature, we might start to see those things. All right. So large language models for insurance, how does that work? LLMs are mainly text generators. They're not problem solvers. They can do limited amount of reasoning, but what is amazing to realize is that large language models have been trained to generate the next word in a sentence. So you give it a partial sentence, and then its job is to guess the rest of the sentence. And that's how it's been trained, and that's what it does best. What it doesn't have is knowledge of insurance. It may have some knowledge, but probably does not have knowledge of insurance specific to the UK or Sweden, Norway, Holland, Germany, and so on. And it definitely will not have company-specific proprietary process information. So we need to build that on top of what the general insurance GPT gives us. What does the InsuranceGPT do for us? It does claims intake, which is basically processing things like the accident report and so on. And then it does claims processing, which is applying the laws of that country to that claim and figuring out which laws apply and which laws will apply to your particular car accident. And what we're going to do is we've started with auto LLM or insurance GPT, but we're also going to move to home claims, travel insurance, and banking, and so on. Okay, so pretty much already said all of this. We have these different countries. We're working mainly in the Netherlands and Norway right now. And we are doing things like processing the company terms and conditions, the ordering of the process, generating emails, generating the assessment of the claim. Okay, what value does IGPT bring to the claim handler? It brings to the claim handler, it focuses the attention to which parts of the claim are the most important. So as I said before, a claim could consist of 10 different documents. And if there are injuries or medical situations, the claim process can last for months. So what we want to do is we want to refresh the claim handler, CH being the claim handler, their memory as to what reports have already been gathered together in this claim, what conclusions have already been reached, any laws that we have found. And the important thing I want to emphasize here is IGPT is an assistant to the claim handler. It is not a replacement to the claim handler. We're not looking to replace anybody. What we're trying to do is help them so that they can find the laws that apply to that particular car accident in a systematic way. Some claim handlers might use different laws than other claim handlers. So you can actually have a difference in the outcome of your car accident depending upon which claim handler you get. And we want to avoid that. We also, most straightforwardly, you can imagine that LLMs are text generators. So in order to generate emails and assessments, that comes very naturally to the large language models. Additional functionalities that we have is we've tried to build confidence throughout the system. So we can say which parts we are confident on. If we're not confident on certain cases, the claim handler can look at that and override anything that the insurance GPT does. So that's the other important thing I want to mention, which is that IGPT is an assistant. It is a recommender in a sense, and it is there to help the claim handler, not to override their job function. InsuranceGPT can process reports before the claim handler gets to work. And one day we could also automatically send out emails. But right now, all the emails that are sent out go through the claim handler first so they can check to make sure it's exactly as they want. So what are the takeaways? We have a full system. It's InsuranceGPT or IGPT is not just a GPT-4. It is a large language model that is fine-tuned on information about laws and policies of insurance companies. It knows how to do lots of things in insurance that GPT-4 does not. It is an assistant. It does not replace human labor. We are very cognizant of privacy and security for GDPR. Car accident information can be very private. We don't want, even people inside Simplify cannot see the data unless they are specific to our project. And for each project, there are different engineers. So we are very, very cognizant about data privacy. And the overall value is that these large language models that we have fine-tuned are chained or organized together in an architecture to become a full system. So the LLM is like a subroutine for us. We probably make about 20 different calls to large language models in InsuranceGPT. And we hope that InsuranceGPT will help claim handlers become more efficient and consistent. That's it.
Thanks for walking us through that. That was very helpful. One of the things I was curious about was in an earlier slide, you had this interesting statement. LLMs are not problem solvers; they are text generators. So there's a school of thought which says that language is not just the way humans communicate; it's also how we think. So by being able to predict the next word, by default, LLMs are able to kind of fundamentally understand how human reasoning works. So that in context with your statement, Kamal, what would you not trust GPTs with?
So it's not a binary question. What would I not trust them to do? It's a gradated question, right? You asked, they are able to pass the bar exam in the United States. So we know that the really big LLMs like GPT-4, which have hundreds of billions of parameters, trillions of parameters, can do enough reasoning to pass the bar exam. And Geoffrey Hinton, for example, has said that in order to predict the next word more accurately, you do need to have an understanding of the interplay of the words. It's an empirical question. When we first started this project, if I had given all the documents in a claim case to GPT, it could not do the work of the claim handler. That's a truth because we tried that. What we had to do was break down the problem into smaller pieces, and then for each piece, the LLM, and we ask it via prompting and so on, and the LLM can do that little piece, and then that gets changed and gets given to the next component in the pipeline. So it can do limited forms of reasoning. I'm not going to say it cannot do any forms of reasoning, but it can also not do all the forms of reasoning that we would want it to do.
One of the things I was curious about was, it's a very simplistic question. The difference between giving these insurance documents to just ChatGPT versus a fine-tuned IGPT. Obviously, the first difference is the domain-specific information that you mentioned that it is trained on. What else is the difference between these two scenarios?
So I would say the difference is that it's fine-tuned on country-specific laws. It is fine-tuned on company-specific processes. That's two differences. Those are the two main differences. The other difference between InsuranceGPT versus GPT-4 is that they're really different kinds of animal. GPT-4 is a general large language model, whereas InsuranceGPT is a full system that runs on a server, right? It has one purpose, which is to help claim handling. It is an instantiation of LLM technology.
Okay.
So that's another big difference, is that it has knowledge coded into it um, in configuration files and whatnot, rules and so on, that are not in the large language model.
Okay. And as you went about this process in the early stages, how did you decide between using an open source model versus a managed service like OpenAI? How's that decision usually made?
Money is a big part of it. So
Okay.
it's for a startup like ourselves, we cannot afford as the number and scale of compute that OpenAI, Microsoft, and Google can do. So most startups will be in a similar situation, that money is a big constraint, and that then has flow-on constraints into what's the maximum context size that it can handle, what's the speed at which it can run, what's the type of hardware that your startup can afford.
Mhm.
So all of that.
And again, you mentioned in your slides about big data being all over popular all over again with the LLMs. So in the context of IGPT, uh, could you help us understand what volume of data roughly uh, uh, is usually needed to train something that actually makes sense in production?
Yeah, I cannot speak to the volume at Simplify, but I can tell you in the
Yeah.
last 5 years, even a few thousand extra training examples can help. So we had one project. It doesn't need to, by a few thousand training examples, I mean like a few thousand paragraphs, let's say.
Wow.
Um,
Mhm.
so that would be, let's say if each paragraph is 100 words and each word is 2 tokens,
Mhm.
uh, it could be just a few 100,000 extra tokens. It all depends on the complexity and variability of the fine-tuning task that you're asking it to do.
Okay.
If there's a lot of variability, then you'll need more training data.
Mhm. Understood. Okay. And just to, and again, this is not simplified specific, but broadly speaking, now let's say in the class of a motor insurance, if there's a specific legal clause that you want the model to map a claim to. Is there a rule of thumb to how many occurrences of that clause should be there in your training data set for it to do a pretty good job of mapping it? Or is it one? Is it 10? Is it in the order of 100? Uh,
That's a good question. So the laws form like a Pareto distribution, right? Or
mhm, mhm,
exponential distribution. There are some laws that apply very commonly, and then there are some laws that are very niche. Let's
sure.
say I would say even just five applications of that law. It depends on how you're able, in the runtime, how you're able to find the appropriate laws. And I can't go too much into that because that's actually kind of a key sauce for us.
I understand.
Um, yeah, but definitely, I talked about big data, but
Mhm,
the big data hump has already been dealt with by the pre-trained model. So in a sense, once we're now in the small data regime,
mhm,
because the general LLM, the pre-trained LLM, has already done so much work, so much training,
mhm.
that it then it affords a small company like Simplify to have a relatively small amount of training data and go a long way with that. Um, yeah, that's the whole idea of standing on top of the pre-trained model.
Makes sense.
So
And
yeah.
what was probably the hardest part of putting together this entire workflow that included IGPT?
Getting the data from the customer is the hardest part.
Mm,
So um, you know, we're not out there scraping everything that's available on the open internet, right?
Right.
Uh, we are in the business of making agreements with our clients, with insurance companies,
Hmm.
and they are very careful about who does what with their data.
Hmm.
So actually getting the data is getting good data might not be the volume that
Hmm.
GPT-4 works with. It
Hmm.
isn't volume that GPT-4 works with, but um, it is higher quality and it is very specific and it is closely guarded by the people who guard that data,
Yeah.
by the insurance companies. The
Hmm.
laws in general are publicly available. Um,
Hmm.
right. So
Okay.
that was actually the thing that took the longest amount of time in our project.
Okay. And
It's,
once you had
it's not
this data,
technically the hard. It's not technically the hardest, but it took
right?
the longest time.
Yeah, and probably has the most downstream effect on your outcomes and all that as well.
Yeah, exactly. It's not, that's why we can't just take the public LLM,
Hmm.
throw throw the claim documents at it and say, here's 10 documents about the car accident claim. What should we do?
Hmm.
Who's at fault? Who should be paid? Now, so it just cannot do that right now.
Okay.
And to be
And
fair, it takes human beings 3 years on average. It takes a claim handler 3 years to become a good claim handler.
wow, that's pretty impressive.
Yeah.
So just to double click on that last point, which is you take the most difficult part is finding the data. And if I was going to train a human claim handler with that data to understand all of that, every human learns in a different way. Is that a similar situation with getting the best output from a LLM, which is, do you chunk things differently? Do you take the data and is there different ways you train the model with, and could you help us understand how that works?
Yeah. So one of the biggest things that we had to do was figure out how to factor the problem into smaller pieces,
Mhm.
um, how to modularize the problem. You call it chunking, um, but yeah, we definitely had to do experimentation with chunking. There's a lot of experimentation with prompting, chunking, zero-shot learning, few-shot learning, all of the above. Um,
Mhm.
Machine learning is partly an art, partly a science right now, in that it's not like engineering where you're building a rocket, you know how much fuel you need to put in it and so on. Here
Yeah.
we experiment with different things to see what works. Um,
Okay. Makes sense. I have this other question, which is not really directly relevant to LLMs, but really relevant to search, because you were part of search in the early days at Yahoo, right? And probably since then, this is probably the first time we are looking at a reasonable chance that search could get disrupted again. Do you think that's more hype than substance, or there is real substance that search could get disrupted with intelligence? Or what are your thoughts on that?
yeah, that's funny because, you know, I'm old enough that I remember the expert systems from the 80s.
Oh yeah,
So
yeah.
expert systems purported to give you the answer, and they
Mm,
failed miserably. Um, because actually humans are not very if the expert system promises that it will give you the answer, then
mm,
even if 99% of the time it does, that 1% of the time which it doesn't, that's the time that you remember it, you know. It's like you go to a hotel or a restaurant and it breaks down 1% of the time, that's the one you complain about, right? Whereas with search, the fantastic thing with the Google search and Alta Vista and those early search engines did was they said, um, here is what we found on the internet. That messaging is super important because
mm,
they're not saying, I'm giving you the answer,
mm,
right? Even now, when I use Google search and it has the AI box at the top, Sometimes it'll make mistakes, and sometimes it'll make mistakes, and the first link
Mhm.
of the organic search will actually have the right answer in it, right? So that's really exasperating. Um, I don't know if it would be a good thing for OpenAI to go into search. Search is a very big thing. People have gotten used to it being really, really accurate. I mean, it's taken Google 20 years to get it so accurate, right? Um, and that's why they haven't replaced search completely with the generated AI answers, because if you look at them, they're not always right. In fact, they could be wrong 10% of the time, right?
Yeah.
And if you're writing code, um, even a small error rate is really, especially if it's hard to find.
Mhm.
Maybe other people have had different experiences, but my experience with getting it to write code for me is that it looks good, and sometimes it has hard to find errors in it.
Mm.
Um, but if I'm learning a completely new language or I'm a newbie, then it helps because my own base is very low, right?
Right.
But if I'm very good at C++ or Java or whatever,
Mhm.
um, then the code that the LLMs will generate might not be that much more useful than what I can do myself. Um,
Makes sense.
it's a
Uh,
quantitative question. Like what you said, will it replace search? Um, I don't know. That's a hard one.
yeah, you're right in the sense that as kind of a paradigm, uh, LLMs provide you output or with a higher degree of certainty than a search does. Because somehow, would you agree that we have somehow come to view an LLM's output with a higher degree of confidence than a search output today?
I don't. I
You
don't.
don't? Okay.
I mean, maybe some people view that. Maybe it's just my age,
Right.
but or maybe it's because I was involved in search.
Yeah.
LLMs are overconfident in their language,
Yeah.
right? So
Yeah.
they don't really modulate. There's no confidence number that comes out of a LLM.
Right.
Um,
But
Search,
that's a very. Mhm.
yeah.
Please go ahead.
I mean, in the very old days, search used to have a confidence number. Google used to show it. Um,
Oh,
yeah, like 1999, 2000, but then eventually it went away because people didn't know what a 8.3 out of 10 means. You know, is it, are you very confident? Is that very unconfident? So now it's just a rank list. But yeah,
yeah.
I think generative AI can definitely be a part of search. I don't know
Mm,
if it will replace search
mm. Got it. But I think you
because
made a really good point about the messaging. Yeah, that's a really good point. I'm sorry, I didn't want to interrupt you. Please go ahead.
it also depends on what you're searching for.
Mm,
Like if you're searching, I'm looking for a particular type of shoe, it's a very specific search,
mhm.
right? You don't need a LLM for that. You can just find a shoe store that's selling that type of shoe,
Yeah.
right?
Yeah.
If you're asking a homework question, then maybe you need a generative AI to help you a little bit with that. Um, but yeah, so we'll see. It definitely has an impact on revenue model though,
Mm,
because a lot of these websites are used to getting click-throughs to them. And
mm,
if Google is using generative AI to answer the question instead of even 25% of the traffic, a 25% traffic reduction could be a death knell for some of these websites.
yeah.
So even if the generative AI takes away 25%, it could be bad for them. But for the end user, we'll see how it plays out. My guess is for certain classes of queries, it will be
Mm,
good. And for
mm,
other classes of queries, it will not make any difference.
mm. Got it. But very good points. One is on the messaging, which is just by the default of an LLM, the bar on what is expected is probably higher because just the general public expect uh, stuff that is slightly more authoritative than search. So it's a pretty high bar OpenAI has to live up to.
Yeah,
And the second point you made about the distribution challenges that startups are going to face because traffic is going to reduce with AGI kind of answers. That's an interesting situation we are all in because with LLMs, it's just become so much more easier to build products, but it's going to get a lot more difficult to get organic distribution through SEO.
right.
Yeah.
Yeah, but Simplify is in a entrepreneur or B2B space, right? So it's
Mm-hmm.
different for Simplify, but definitely for um, websites that depend upon customers, everyday customer coming in.
Yeah.
Um, if they're the best shoes, not the shoe store example, but Quora, for example,
Mm.
how's that going to do?
Yeah.
Or Stack Overflow, right?
They've dropped by, I think the traffic dropped 30-40%.
Yeah, they've
Yeah.
decided to throw in their hat with the LLM side,
Right.
right? Because
Mm.
but that's kind of weird for all the people that have contributed answers there for thousands, for 20 years, they may have senior engineers have been contributing answers on Stack Overflow, and now suddenly someone else will monetize that.
Mm.
That's kind of strange. So I don't know how that's all going to shake out. I think definitely creators should be paid in some way. That's my feeling.
What do you think can go wrong with the whole, or do you think we have past the point where things can't really go wrong that bad anymore? AI will deliver on its promise largely. If not, what will derail that promise?
What could go wrong? Um,
That this is just another PR press cycle of 24 months. We'll get past it.
oh, I'm sure there's an element of that.
Okay.
The media love to sell clicks,
Mm.
right? That's their job, right?
Mhm.
So when Gen AI is coming up, they'll hype it,
Mm.
overhype it, and then when the overhype doesn't deliver, then you'll start seeing articles saying, "Is there too much hype?" So the journalists win on both sides. They win on going up
Right.
the hill, coming down the hill.
Mhm.
Uh, so, but as for what can go wrong, my worry is mainly uh, how will militaries use, like if we do get um, agents that can do reasoning,
Mhm.
um, and you marry that with a weapons platform, you know, and now you have a
Scary.
weapons platform that can do some type of reasoning. Where's that going to go?
Yeah, that's scary. Yeah.
Yeah.
I
So,
might be wrong here, but I think I recall saying the 4.0 or something. OpenAI claimed that they're putting guardrails around defense usage. Might have, was it 4.0 or some other model? I'm not sure, but yeah, that's a real scary scenario. Yes, yeah.
if you're a military, you want the version of the LLM that's fine-tuned to not have guardrail.
Right,
That's your job, right?
right. Yeah.
So, it's interesting. I was in Rexis in 1998, Recommender Systems Conference, and we were so excited that we could recommend to each person their customized news. And the social impact of that has been that now, in the last 8 years or so, we're
Mm.
living in a fractured reality. We're living in a reality where certain groups of people get only news that conforms to their beliefs.
Mm.
Other people get a different set of news, and that was not at all a foreseen consequence of recommender systems. We thought we're doing a great job. We're giving people what they want, you know. what kinds of movies you want to see, what kind of news you want to read, right? And so it's just super, super difficult to predict all the downsides and unintended consequences. There's just like no human being on this planet that can do that. So we're pretty, even the people that are deep in this field cannot see the consequences of it even 2-3 years out, probably. I'd say. Yeah, we do need to be careful with it.
Yeah, fantastic times we're all living in right now.
Yeah, it's incredible. There's a movie I love called Her, and when you watch that movie and compare it to what GPT-4 Omni is beginning to look like, it's just incredible.
Right, exactly. Well, I think this is 4 or 5 different voices you can select. One of those I was selecting yesterday on my GPT app is scarily close to the voice in her. So
Scarlett Johansson's voice, yes.
yeah,
Wow.
awesome. Yeah, thank you so much. This has been just fantastic. So much inputs and perspective.
Thank you. My pleasure.
Really appreciate your time.
Thank you.
Thank you.